Hi all. In this lecture we will discuss about transaction layer packet. In the previous video we saw that logically PCI architecture can be divided into three layers: transaction layer, data link layer and physical layer. Two PCI devices interact with each other through PCI link, which is serial point-to-point interface. If it were parallel interface, then both devices could interact using handshaking signal. Like it will PCI device will set that address. Along with that, it will send that valid signal saying that address is valid. Now device B will send ready signal. When valid and ready are asserted, address is less than device B. But here it is serial interface. We can't use these handshaking signal. Only one signal is used. So over that, data is transmitted in the form of packets. These packets has predefined meaning. Now, if let's assume that there is one initiator in device A, X, which wants to interact with device B, Y. So here it will initiate a AXI transaction. That AXI transaction will be converted into packet in transaction layer and will be passed to data link layer. Data link layer will pass it to physical layer, and through physical layer it will go through PCIe link. Now physical layer will receive it, and then data link layer and transaction layer. Now transaction layer will receive this packet, same packet. It's the responsibility of transaction layer to convert this packet into AXI transaction again. So this packet should contain all the information required for creating this AXI transaction. Okay, let's see that when we transaction layer receive the AXI transaction, this transaction it converts into packet, and this packet has three fields: header, data and ECRC. Here ECRC is optional. Data is also optional and is there in the case of write transaction. So most important part is header. It contains all the properties of the AXI transaction which are required. So using this header, receiving PCI device will regenerate the same AXI transaction. So this packet is passed to data link layer. In data link layer, LCRC and sequence numbers are added. LCRC link CRC, it is required field. Sequence number is required for keeping record of all the packets. It is passed to physical layer. Now in physical layer, framing bytes are added. Framing byte like start of packet and end of packet. Now this packet is transmitted over PCI link serially. Here we can see that. Now when PCI device B receives this packet, in physical layer framing bytes are removed and rest of the packet is passed to data link layer. Now in data link layer again, sequence number and LCRC is removed and passed to transaction layer. Here we are not talking about error scenarios. We are saying that everything is fine. So that's why these packets are passed to next layer. Now in transaction layer, header contains all the properties of the transaction. After decoding the header, transaction layer generates the same AXI transaction which were created earlier. And reaches to Y. Let's see the packet in more detail. These three field of packets are generated in transaction layer. Here ECRC and data are optional. Data is used in case of write transaction and can be of up to 1 kilo words or 4K bytes. ECRC is 4 bytes. Header, it can be 3 or 4 double word depending upon the transaction type. In DLLP data link layer, sequence number and LCRC are added. LCR is required field and it is of 4 byte again. Sequence number is of 12 bytes. When it passed to physical layer, framing bytes are added. These are of 1 byte in the start and 1 byte in the end. So we know that when this packet is received, then first in physical layer framing byte will be removed. In data link layer sequence number will be removed and LCRC will be removed, and then in transaction layer from header same transaction is reconstructed. So this packet or header contains the format of the packet. We will discuss it again. Format means header can be of 3 double word that we discuss or 4 double word. Header can have data or no data. Or header can have TLP prefix that we will just touch upon in this lecture. Type of the packet, we can have memory transaction, IO, configuration, completion, atomic transaction. So point is, from the header we should be able to decode this information. Length of the associated data. When we say that data is optional in TLP and when it is write transaction there should be data, and what should be the length of the data. Transaction descriptor. It provides the information about the transaction like transaction ID. Transaction ID contains requester ID and the tag. Like each requester can create more than one outstanding transaction. So for keeping record of outstanding transaction, tag is used. In PCIe Gen 4 it is 10 bit. Attributes. Attributes informs about the order of the transaction. And snooping or no snooping required. Traffic class. Traffic class is created in the software using software, and we can have up to 8 traffic class, and traffic class 0 is required. This traffic class is used for mapping to virtual channel which is in transaction layer. So traffic class to virtual channel mapping is done in software, and depending upon that priority, we can assign the traffic class to any transaction of address routing information. This transaction can be routed through addresses and through ID. That we'll discuss how it happens. Byte enables. When we initiate a transaction, we need to tell that what are the bytes enable of the first double word and the last double word. That is done using byte enable. And message encoding and completion status. So there are messages used for passing information to one endpoint or many endpoint. When it is one endpoint, then messages are encoded using ID based, that we'll discuss, and completion status. Like if we initiate a transaction, read transaction, we get its completion transaction. So in that we get the status. So a transaction is completed successfully or not. Okay. In this now we will discuss about the different kind of address spaces and transaction type. Okay, in PCI devices we can have memories. So all these memory can be accessed through our PCI link. To know that what is the memory range, we configure PCI configuration space. So every endpoint has configuration space. In this configuration space, we have special register called bar register, which configures the memory addresses which are part of this endpoint. So we can have memory transactions. So, and we can have 32-bit address space or 64-bit address space. For memory, we can have 32-bit address space or 64-bit address space. 32-bit address space can be with data, or 32-bit address space can be without data. Why we are using this terminology, we will see. When it is with data, then it is write transaction. When it is without data, it is read transaction. For write, we have the MWR, read, MRD, and MRD lock. This is legacy PCI endpoint supports memory read lock transaction, but native endpoints doesn't support it now. This is for backward compatibility. We have completion transactions. If CPU wants to read some data from an PCI endpoint, then memory read transaction is initiated here. It sends the acknowledge. Means this memory read transaction has reached to switch and everything is fine. And similarly, now switch sends this memory read transaction over here and sends the acknowledge. It means one transaction is completed. When PCI device will have the data required, it will send the transaction completion with data. CMP with data. CPL, sorry. So this completion with data. It can be completion with data or completion without data. There can be error, so it will send that completion only. Locked memory read transaction, if a device receive that memory read locked transaction, so it will send that locked memory read without data or locked memory read with data. IO transaction. Similar as we saw that any PCI device can have memory address space, but legacy PCI device will have IO address space, not the native PCI devices. It can be 32-bit, it will be with data and without data. So with data it is IOWR, and without data IORD, symbol for the transaction. Configuration. To work properly, switches has its own configuration space, devices has its own configuration space. This is called type 1 configuration space, and this is a type 0 configuration space. During enumeration type, these configuration spaces are configured. Whether it is of PCI device, endpoint or switch, for all there is a process called enumeration. So configuring this configuration space, a type 1 for switches, type 0 for endpoints. It can be read or it can be write, both. Type 1 read, type 1 write, type 0 read, type 0 write. So configuration read 0, configuration read 1, configuration write 0, configuration write 1. Messages. So messages can be like any CPU can send messages to all the devices or to specific device. Let's suppose to this device or this device. And devices can also send messages to CPU. One example is like interrupts are sent through message called MSI. And messages can be with data or without data. So we saw that address spaces are memory and IO, and address spaces are memory and IO, and type of transactions are memory read, memory write, and completion, configuration, and messages. So why we are reading this? All these messages, all this information should be there in the header when transaction layer convert the transaction into TLP header. By reading TLP header, we should know all these information, which kind of transaction it is, whether it is memory transaction or IO transaction or configuration transaction or message, is it 32-bit or 64-bit, all these information should be there in the TLP header. Okay. Posted transaction. It's a terminology we use, that posted transaction or transaction which doesn't have the completion. Like we saw that when CPU wants to read from this endpoint, let us for PCI endpoint, memory read transaction will be issued, and from here completion, after some time completion with data will be issued from PCI endpoint. But if we want to initiate memory write transaction, then there is no completion for that. So these transactions are posted transaction. Like we initiate the transaction and forget about that. So PCI protocol makes sure that this transaction reaches to its destination. Similarly, we have messages. Non-posted transaction are the transaction which have the completion. As we discussed, memory read are the non-posted transaction, configuration read and write also have, and IO. Okay, next one terminology is split transaction. We already discussed when we initiate memory read transaction, we get its acknowledge. And after some time, when device has the required data, it initiate new transaction, completion transaction with data. So main transaction is split into two transactions called split transactions. Okay, now let's see the TLP header. We said that TLP header can be of 3 double word or 4 double word. We'll see when it is 3 double word, when it is 4 double word. Here we are starting with byte 0. Normally we start byte 0 from right, but in case of TLP header we start with the left. Serially, this by bit 7, this data will go through PCI link first. If we see byte 0 has two field, format which is of 3 bits and type. These are some bits field which is required to capture all the properties of the transaction, like tag 9 and tag 8. These are for the outstanding transaction. These are added with the tag 7 down to 0. Tag 9 and tag 8 are added in PCB Spec 4 only. Traffic class. So traffic class we discussed, it can be from 0 to 7. Traffic class 0 is required, and traffic class to virtual channel mapping is done in software. Attribute is of 3 bits. 1 bit tells that ID ordering, relax ordering, and no snooping. So we will see TLP hints. Here we have some TLP hints for creating the transactions from TLP. TLP digest, if this bit is set, ECRC will be present. If this bit is not set, it means ECRC is not there. Error poisoning, if on the way transaction is corrupted, then error poisoning bit is set to complete the transaction. So receiving PCI device will, when show this error poisoning bit set, it understands that the transaction which is receiving is corrupted, so it just accept this transaction, flush it. Address translation is used for translating the address, and it is not in this lecture we will discuss. It is complete new spec, separate spec, considering virtualization and all. Data length is of 10-bit field. It tells that the length of the data which is present in the TLP. We told that this is maximum is 4K bytes. Requester ID tells that which is the request ID of the requester. It starts, we calculated the ID using BDF, bus device function, that we will discuss in detail. So when we initiate a transaction, so first double word and last double word byte enables are tabled from here. If we have 32-bit address, then we use 3 double word. If we address is 64, we use 4 double word. Okay, now we will discuss about the format. Format tells that header double word size. It can be of 3 double word or it can be of 4 double word. And header can be tells that it is TLP is with data or without data. With data or without data. When it is say that with data, it is write transaction. When it says no data, it is read transaction. TLP prefix. Sometime before TLP prefix is added, so it gives that information. We are not covering in this lecture. Okay, so this is the table which is provided in the PCI Based spec also. We will just see some points. Here, type, which is 5-bit, tells that is it memory transaction. We see that all bits are 0 in that case. How we know that the address is 64-bit or 32-bit from the format. When format is 0, it is 3 double word. Format value is 1, it is 4 double word. And how we know that it is read transaction, write transaction? With this bit. It tells that it is 32-bit with data memory transaction. 64-bit with data memory transaction. Similarly, this tells that IO transaction, and it tells that IO transaction without data. When we say that without data, it is read, and here it is IO transaction with data. So it means memory write. Configuration transaction, it tells that configuration transactions. It here format tells configuration transaction with data means write. Configuration transaction without data means read. Here this is configuration 0. Configuration 0 for devices, configuration 1 for switches. Again, with data, without data. 32-bit, both are 0. So trusted configuration. This type tells a trusted configuration. It was used earlier but now depreciated. If we receive this type field, it means there is malformed error. Again, just for understanding, these bits tell it is without data or with data. If without data, it is read. With data, it is write. Messages. Messages can be of 3 double word or 4 double word. Messages will be of 4 double word, sorry. Here it tells that it is with data or without data. This field tells it is message, and this field tells the type of message, R2, R1, R0. So we know that PCIe is split transaction, so in that completion. Now again, completion with data, completion without data, without data, with data. Completion lock, without data, with data. These are atomic transaction, fetch and fetch address. In that, what happens is, after TLP header, we give the data in which it, so usually whatever address is there in that header, it fetches that address, added the data which is after the TLP header, and store it back. So address can be 3 double word or 4 double word. We know about this. And here we need to send data after the TLP header, so we are saying 1. Swap, again we send the data after TLP header, so it is 1. In swap, we just swap the value with the value which we are sending. It is 3 double word or 4 double word. Cache, compare and swap. Again, we need to send the data and 3 double word, 4 double word, and this is for type is that this transaction is atomic transaction, compare and swap. Local prefix, we discussed in format when bit 7 is 1, then it is prefix. For local prefix, type is 0. For end-to-end prefix, type is 1. And we will not discuss more than this in this lecture. Data length. This data length, we know that it can be up to 4K byte or 1024 double words. So when its value is 1, it means 1 double word need to be transmitted, or in case of write, 1 double word is to write. In case of read, one double word need to be read, and its value is 0, 0. It means 1024 double word need to be write or written or read. Transaction routing. How transaction is routed? One is address based. We discussed that every device has configuration space. In this configuration space we have bar registers. So these registers contains the addresses which are of this particular device. So when any memory read or write transaction comes, the addresses are compared with the addresses which is in the bar. If these addresses are of in the bar, then this transaction is accepted by PCIe endpoint. So address based routing happens this way. So memory and IO transaction. So we discussed that there are 5 kind of transaction: memory, IO, completion and configuration, message. Out of these 2 type of transaction, memory and IO, uses address based routing. So address can be of 32-bit 3 double word, address can be of 64-bit 4 double word. So memory read write atomic operation 32-bit and 64-bit address operation. For memory we can have 32-bit or 64-bit IO read write 32-bit address space. So just for 32-bit address spacing we will have 3 double word in the header, and here we will have in the last double word will contain the address 31 down to 0 or 2 bits are for PH for TLP hints, which we will not cover. For 64-bit address routing we will have addresses in the last double word 2 and double word 3, again PH. ID based. Okay, now we know that every switch and device has configuration space. To configure configuration space, we uses the ID routing, which is used using BDF, bus, device and function. This is of 8-bit, device is of 5 bits, function is of 3 bits. It is of 8-bit means we can have up to 256 buses in PCIe topology, and each bus can have 32 devices, and each device can have 8 functions. 2 raised to power 3 is equal to 8 function. Here I will write 2 raised to power 5, 2 raised to power 8. When enumeration happen, so root complex has the primary bus called bus 0, and this will be called bus 1. There will be bus inside switch, it will be called bus 2. Now in enumeration this will be bus 3, bus 4 and bus 5. So devices connected to bus 1 will be this device called device 0, and it will have function 0. If we talk about devices on connected to bus 2, so there will be one device this, device 1, one device this, device 2, and one device this, device 3. And on devices we can have functions. So depending upon which PCI endpoint we want to access, we know its bus number, on which bus it is, device number and function number, BDF. Using this information, we can initiate any transaction and it reaches to its destination. So what kind of transactions? Just now we saw that there were 5 types of transaction. Out of these 2 transactions, we use address mapping with using address-based routing. So for other 3 transactions like configuration, messages, ID based messages, and completion, messages can also use address routing. We use the ID routing. ID routing uses bus device function number. ID routing format uses 3 double or 4 double header type. ID routing with the 3 double, we said that we have a bus number 2 raised to power 8, device number 2 raised to power 5, and function number 2 raised to power 3. ID routing uses 4 double word. So all the transactions which are completion and configuration, you have 3 double word header. Only messages can have 4 double word header. Okay, so if we have 4 double word header, in that byte 4, 5, 6, byte 8 and 9 are used for BDF. First and last byte enable rules. So that byte 7 contains that first double word byte enable and last double word byte enable. This is for memory transaction, IO transaction, and configuration transactions. Let's assume that we want to read 42 bytes and the starting address in the address it's 32 bits, so it will be our 3 double word, and let's just start that starting address. We gave the 400 and we will have some bits. Okay, and but we want to read from the 402. We can't give this 402. We can only give, because last 2 bits are resolved, so only give the address of in the 1 double word granularity. So how we can achieve this? We can set that first double word byte enable to 0011. It means at 400 whatever byte we want to read, it will be 0. So byte enable is 0. We don't want this byte. For 401 byte is not required. 401, 402 and 403. First double byte read should be 402. After that all bytes will be read, and when we reach to last double word, so first we read the 2 bytes, and after that we read for 9 double words. We read, this is, let's move the first double word, second, third, fourth, fifth, sixth, seventh, eighth, ninth. All double words we read, and byte enable is implicit to be set for them, because there is no byte enable for this. So how many bytes we have read? In fact 10th also we have read 38 bytes. Now 11th double word, when we will read, how many bytes we require? 4. Or if we want to read 43 bytes, so we will read 11th double word. By that we will read 42 bytes. And for 12th double word, we require only 1 byte. So for that, last double word byte enable should be 0001. It tells that only one byte we want to read, rest we don't. Okay, so it says that if we are doing memory read, TLP hints bit is set, then instead of byte enables field, we will have staging tag. So in that case, if we are reading one double word, so it's implicit that all the byte enable will be set. Point is, if TH bit is set and we are reading some memory, and then byte enable will be set for all the bytes which we are reading. Similarly, for all the bytes of the last double word will be set. So means if TH bit is set and we are reading some memory, then all the byte enable will be assumed to be set. Zero length write. We can have zero length write when we are writing one double word, data length is one double word, and we haven't enabled any byte enable. All byte enable are 0, then it will be zero length write. Useful for lightweight notification protocol. This is separate, we will discuss in separate chapter. Similarly, zero length read. In zero length read, when we are reading one double word, no byte enable are set. This is zero length read, used for flushing request. If we want to make sure that whatever data we have written using post write transaction, then we use a zero length read at the same address. It makes sure that if this address, it makes sure that whatever data we are writing on this address is written. Transaction descriptor. So transaction descriptor has 3 fields: transaction ID, attributes, and traffic class. So transaction ID contains the requester ID and the tag. Requester ID is again BDF. It tells that which function has initiated this transaction. In BDF, 8 bits are for bus, device 5 bits, function 3 bits. Tags tell that transaction which are not completed yet. Earlier it was 8-bit tag. Now 2 bits are added and it becomes 10-bit tag. We can make this tag, we can expand this tag further in the case of phantom functions. Phantom functions are those in which device has only one function. So 3 bits of this function can be used for tags. So we can have 8 folds of tags. Original value, 8 fold of original value tag. Attributes. So these attributes are required for ordering and snooping. So attribute 2 and attribute 1 down to 0. ID based ordering and relax ordering, no snooping. So ID based ordering is if a transaction from a same device will be ordered Relaxed ordering means different type of transaction can be ordered, or switch can order the same type of transaction, assuming it has received message transaction and write transaction. These transaction can be reordered by port. If both attribute 2 and attribute 1 are 0, it means default ordering means strong ordering. There will be a transaction will come in the same order in the which they receives any port. 0 1 relaxed ordering, in which, like, if we receive two transactions, as I discussed earlier, memory write transaction or message transaction, depending upon that availability, it can be ordered or reordered. ID based transaction ordering. So depending if this bit is set, it means that ID based is ordering. If we have different IDs, transaction originating from different devices, it can be reordered. When 1 means relaxed was ID based ordering. So this transaction or this topic we will discuss again when we will discuss about credit based flow control. So we will know that when transaction can be stopped, one kind of transaction can be stopped by port. So for it is saying that attribute 1 should be reserved and clear for configuration, IO and messages. So why attribute 1 should be reserved? Attribute 1 said that relaxed ordering. For configuration transaction, we don't want relaxed ordering for IO and messages. Attribute 2 for configuration and IO. No snoop. If we know that any transaction which, if we like, we want to read transaction from the memory, if we want to speed up that transaction and we know that content of that particular address is not in cache, then we can enable the no snooping. Otherwise, what will happen if we initiate a transaction? First, that transaction will be read from cache. If cache doesn't have data, then it will go to main memory. So it means slow down the transaction. If we are sure that the data is only in main memory, then we can enable this no snooping attribute. So this field is not applicable for configuration request, only yes, IO request, memory, message signal interrupt and message request. So this kind of transaction require memory read. Now transaction descriptor, traffic class. We discussed that it's a 3-bit field. Traffic class 0 is mandatory, and for IO transaction, traffic class 0 is used. At least traffic class 0 should be supported by every PCIe device. Traffic class 1 to 7, software assign this value and map these to virtual channel. And depending upon priority and round robin, weighted round robin, so differentiation happens, or transactions are serviced accordingly. TPH rules and address translation. I told earlier also, address translation, like for virtualization it happens, so it's a separate specification. TPH rules, if TLP hints are bit is set, then some rules are there that also we will discuss in next or separate chapter. Thank you all for watching this video.